Hello everyone. Welcome to our channel. In today's video, we will design the layout of CMOS NOR gate using Microwind. The practical is from VLSI CMOS Design Lab of JNTUH curriculum for ECE department. So let's begin. In our previous video, we created a CMOS inverter layout using PMOS and NMOS devices. However, it is quite evident that complex circuits are challenging to lay out directly. Therefore, we prefer generating a netlist from a schematic and then using an EDA tool to convert this netlist into a layout. In this experiment, we'll design a NOR gate from a schematic. We'll then convert these schematics into layouts using the Microwind tool. In a NOR gate, we have two PMOS transistors connected in series and two NMOS transistors connected in parallel. To begin, double-click on the DSCH icon to open the DSCH window. Once the DSCH schematic entry tool is open, you will notice a symbol library available. Then go to View tab and click on Zoom Out option multiple times. This will help us to place various components in schematic in a better way. First, let's design a simple NOR gate. For the NOR gate, drag and drop the PMOS icon into the schematic window. Repeat the same for second PMOS. Similarly, drag and drop two NMOS transistors in the schematic window. PMOS transistors are placed such that we can connect them in series, while NMOS transistors are placed such that we can connect them in parallel. We'll do the same with another PMOS device. Then, place a ground connection and a VDD connection in the schematic. The ground will be connected to NMOS devices while the VDD will be connected to PMOS transistor. Our design includes two clock inputs. For the output we shall connect a LED. Let's rename our blocks so that one clock input is labeled A and the other B. To do that, click on the clock symbol in schematic to open the options. You'll see that the period of B is twice that of A, ensuring the input clocks vary. To connect the components with each other, click on Add a Line icon in the menu. Next, we'll make connections between the transistors, input clocks A and B and output LED. Creating a schematic is straightforward, allowing easy connection between nodes. Once aligned, connecting CMOS connections becomes simple and effective. We shall short one NMOS and one PMOS for input A. Similarly, we will connect one NMOS and one PMOS to input B. Finally, a LED will display our output, and since this is a NOR gate, we'll label it NOR_out. We'll then connect this to the output. Now, we're ready to run a simulation. Click on Run Simulation to see it in action. After a few seconds, pause the simulation and click on the timing diagram to verify the NOR gate's operation. Expand the signal to check if the NOR operation is being correctly executed. Save your file by selecting Save As and naming your project NOR_basic_lab09.sch. Then, go to the File menu and select Make Verilog File. This will generate a Verilog file containing the NMOS and PMOS definitions, which you can see in the schematic window. The module name will match the project name. Click OK without making any modifications. In the folder where you saved your project, you'll find the Verilog file saved as a txt file. Right-click on it, choose Rename, and change the extension from txt to .v. Confirm the change to convert it into a Verilog file. Next, click on the Microwind icon to open the program. Click on Compile, then Compile Verilog file. Select the Verilog file that we have created from Schematic. You'll be presented with options like metal layers and floor plans. Click on Compile and then back to Editor without making any changes. If you recall, we originally had two NMOS and two PMOS devices. However, due to a library mismatch, 6 PMOS devices appeared. Close Microwind, start a new session. Once the Microwind is open, go to File tab and click on Select Foundry option. As we had taken 0.12 micrometer PMOS device, we shall choose a foundry suitable to our device length. For example, 0.35 micrometer foundry will be suitable for our design. Hence, we shall choose 0.35 micrometer foundry. Once again, we shall compile our Verilog file created from Schematic. Now, you'll see just two NMOS and two PMOS devices. All the input and output nodes along with ground or VSS and VDD are already connected in the layout. Click on Show Palette icon to see layout components. Connect a VDD node to NWEL region also. Now you're ready for another simulation. Click Run Simulation to view the results and verify the NOR gates operation. Observe the power consumption and voltage versus current values. Any changes require you to hit the reset button. Click on Frequency versus Time tab to see the change in frequency during operation. Use the FFT option to examine the frequency spectrum. Now, you can see the highest operating frequency of our device. Click Back to Simulation to return. Close the window, after confirming our circuit works as intended. This completes the layout for a simple NOR gate using Schematic to layout conversion. Finally, save your design as a MSK file for future use. Similarly, we can design and simulate a NAND gate and convert its Verilog file to a layout. We've just walked through the detailed steps of transforming a schematic into a physical layout for CMOS VLSI design, using DSCH and Microwind tools. This process is crucial for anyone looking to deepen their understanding of electronic design, from theory to practical application in silicon. Keep practicing these techniques to master VLSI design. Visit our blog for more tutorials that bridge the gap between classroom learning and real-world engineering challenges. Do not forget to subscribe and like our channel. So until next time, happy designing.